All right, here we're looking at section 3.6, and we're really going to be dealing with transformations of linear functions. So our big learning targets for today, we're going to translate and reflect graphs of linear functions. Then we're going to look at stretching and shrinking those graphs, and then finally we're going to combine transformations. And that combining just means we're doing more than one thing at a time. So here's our first core concept. So first thing is a translation. When I translate a graph or a function, I literally just shift it. I move it up, down, left, right, but nothing else changes. It stays the same way. It stays the same orientation. It's literally like I just moved it. So a horizontal translation is going back and forth. And one thing I want you to notice is horizontal transformations, any transformation that deals with horizontal is inside the parentheses. Okay, so you'll see this horizontal translation. I've got this y equals f of x minus h, and you'll see that my x minus h is inside my parentheses right here. And that's really important to notice because that's going to be the same always. So what we really also need to be careful of is this is always going to be a minus sign. Okay, so if I see something inside my parentheses, I kind of have to work backwards. So when h is positive, right, so if h is positive, it'd really be like x minus 4, and that actually tells me I move to the right. So when h is positive, or when I see x minus something, that tells me that I'm moving to the right, and that x minus a negative, or so x plus, would be moving to the left. So you see here, I just literally take my entire graph, and this black line is what we call our parent function, right? That's like I've done nothing to it so far, so this is just my parent function. And it's always kind of where we start, and then we do some transformations to it. So I start with my parent function, then I move it either left or right based on what's inside my parentheses here. So I'm subtracting it from my inputs. So the other thing I have is a vertical translation, and vertical means up and down. And so you'll see, notice that this vertical is outside the parentheses, not inside. So this is just how we kind of know which direction it goes. So when k is positive, again, I start with my parent function. If k is positive, I move it up, and if k is negative, I move it down. So now let's look at an example of working with this. So here's my function. I have f of x equals 2x minus 1. So graph this, and I always like to start by graphing my parent function, and then I see I'm going to graph g of x, which just tells me a different function that I'm doing stuff to. And I see I have an f of x plus 3, and then an f of x plus 3. So you see I have both of them are plus 3, but they're in different locations, and they actually do very different things. Okay, so let's look at it. We're actually going to go this way. So for that first one, so first thing we always graph our parent function, and you'll see that's here in this black graph. That is literally when I just graph my f of x equals 2x minus 1. So just a reminder, to graph that, I start here at my y-intercept, and that's at -1, so I graph that point. And then my slope here is 2, which tells me I go up 2 over 1, up 2 over 1, and then I connect those dots and graph my parent function. So with this g of x, I notice that this plus 3 is outside my parentheses, and outside means it's vertical, right? Outside is up and down. So that tells me I go up 3. So I literally take my whole graph and I shift it up 3. So I also want to show you kind of what that looks like in Desmos. So I'm going to 2x minus 1. There's our parent function, right? That's the graph that we just started with. Oh, I'm sorry, I had 2x minus 2, 2x minus 1. There we go. So then I can take that same graph, and you'll see that it marches the same. And I noticed that my plus 3 was outside the parentheses. So what I'm going to do is I'm going to put this in the blue graph inside parentheses, and then I'm going to add 3. So you'll see that Desmos can also help me see it and just reorganize it so it's visible for me. So the other thing that I can look at is mathematically what I'm doing. So I started with 2x minus 1, and that was just my parent function, right? So then I know I put that in parentheses, right? And to it, I add my k value, and my k value here was 3, so plus 3. So now I can see I just have a simple math problem that I can simplify. So now I have 2x, and then I know I can combine these terms, so minus 1 plus 3 gives me plus 2. And I can graph that new function right there, and you'll see that as well. Okay, so now I see I've got this plus 3 inside my parentheses. So that's going to actually change things quite a bit. So since it's inside my parentheses, that tells me that's where I'm moving left and right. So I know that I have x minus, and I always kind of start, so x minus, and then this will turn it into a -3. So I would end up getting my +3. So that tells me that it's moving to the left. So again, I can just graph it in Desmos, right? So the red one again is my parent function where I started. The thing here is that in order to get it to go left and right, this that's inside the parentheses needs to go into wherever x was in my original equation. So now I have it's inside the parentheses, so that changes a little bit. So x plus 3 and then -1. So all I've done is I've substituted this in wherever there was an x. Then I can simplify and distribute. So now I have 2x plus 6 minus 1, and simplify some more, so 2x plus 5. And you'll see that it shifted my y-intercept, and it moved the entire graph to the left 3. So we can look at this graphing it. We can also just notice that, since this is inside my parentheses, it's moving to the left and right, and here, so it's going to go left. We can also just mathematically kind of come up with our new equation. Okay. So the next thing we talked about is a reflection. So reflection is where we kind of flip our graph. So again, when I reflect in the x-axis, and you'll see this right here is my x-axis, right? That's going up and down. So if you were to flip here, it's kind of an up-down flip. So my negative sign, which tells me we have a reflection, is outside the parentheses, and it's outside kind of the function. Here, my reflection's in my y-axis, right? This is kind of a reflection going this way. That's left and right. That's going to go inside my parentheses. Okay, so let's kind of remember inside and outside our parentheses to get us going on this. So here's my parent function. So I have f of x equals 1/2 x plus 1. So then I graph it. Here's a negative outside my parentheses and then a negative inside my parentheses. So remember, outside means up and down. Inside means left and right. So that's where I'm going to be reflecting. Okay, so I can mathematically figure this out. So what we do is we can find some points in our original graph and then turn it negative. That's what that negative outside it means, is I take the solution I already have and make it negative. And so here you'll see this black line again is my parent function, and then a reflection is I just take its distance from the x-axis and graph that new point. So if I was starting with this graph, this black graph, and just said, so graph a new reflection for me, I would find a point on my graph, and I say, from here it is 2 units up from my x-axis. To regraph it, it's going to go 2 units down. And same thing on this side. If I looked at this point, this original point, it's 1/2 of a unit down, so my new point will be 1/2 of a unit up. That's another way that I can reflect it that way. Okay, so now let's look at our second piece. So here I see I've got that negative x inside my parentheses. That tells me that anywhere there was an x, I have to plug in a negative x. Okay, remember, whenever it's in parentheses, I switch it there. I put it into where the equation was. So again, I can see that I've reflected it this way. Okay, so again, I can just plot some points and figure out where my reflection goes. You want to always start by graphing your parent function, and then from there you can kind of see what you're doing and see where it goes. So here's just a couple if you really want to check them out and really use Desmos to help you with this one. Okay, so our second learning target was dealing with stretches and shrinks. Okay, and we use an A letter to denote stretching and shrinking. Okay, so think of a stretch as like if I was to pull on the top of your head, you'd get taller and skinnier. And if I was to shrink you, that would make you kind of shorter and fatter. So that's really what we're looking at. And I really kind of want you to focus over here on our vertical stretches and shrinks. This is what we're really going to be using a lot. So again, vertically means up and down. Do you see again how my A value is not inside my parentheses, it's out front. And that's the big important part. That tells me it's a vertical. So if I have a vertical stretch, that means my line is going to get taller and skinnier. If I have a vertical shrink, and that's where my A value is going to be a fraction, right? Because we don't want to deal with negatives because that's a reflection. But if my A value is little, that means it's going to be kind of shorter and fatter. One thing you really want to make note of is when I have a vertical stretch or shrink, my x-intercept stays the same. So this point does not change, right? Just the slope will change. So then I also have horizontal stretches and shrinks, and horizontal, right, is going this way. And you'll notice, again, my a value is inside my parentheses. So here my y-intercept stays the same when I'm doing a horizontal stretch or shrink. So here, right, I'm going to get taller and skinnier when it's greater than 1, and it's going to get kind of shorter and fatter when it's less than 1. So now let's look at an example. So here's my parent function. I've got f of x equals x minus 1, and you always want to start by graphing that to see what it looks like. The one thing I notice here is this is a fraction, and it's inside my parentheses. So that tells me it's going to be a horizontal, so going back and forth. So let's take a look at what that looks like. So here what we've done is we've graphed our parent function, which is the black one, and I know that it's a horizontal stretch or shrink, so I know my y-intercept stays the same, and all I know is I am having a different slope. So I multiply all of my inputs, and here we can just pick some random x's. That's where these x values came. They just picked random x values and multiply them by this fraction and get our new values. Okay, so it's definitely shorter and fatter, which would be a good indication by this as being a fraction. So now let's look at our next little piece. Here, this 3 is outside the parentheses, so that tells me it's going to be going this way. It's also a fairly big number. It's bigger than 1, so I think it's going to get taller and skinnier. So let's look at what it looks like. So again, since I know that this is a vertical, going up and down, stretch and shrink, that tells me that my x-intercept is going to stay the same. So you'll see that here. So first graph your parent function. Your x-intercept stays the same, and then we just know we're going to get taller and skinnier. So again, we can pick some random x values, whichever x values you want, and just simplify and solve them that way too. So here again, right, we're looking at something very similar. So I've got my x plus 2 as my parent function, so we're always going to graph that. Oh, here my whole number, my bigger number, is inside, so that tells me we're going to be stretching and shrinking going across, which tells me that my y-intercept is going to stay the same. So let's take a look at what that looks like. So here we go. The black one again is my original parent function. My y-intercept stayed the same. It's going to be tall and skinny because it's a whole number that's bigger than 1. So again, my graph got taller and skinnier by a factor of 4. You'll notice that too when we keep working on these problems. Okay, so for the second part, here's my stretch or shrink. This is going to be a shrink because it's less than 1. It's outside my parentheses, which means it's going to be going this way, up and down, which means that my x-intercept is going to stay the same. So if we look at what that graph looks like, let me scroll down just a little bit. So here's my parent graph, the original one. My x-intercept stayed the same, and since this is a fraction, it's going to get kind of shorter and fatter by a factor of 4. So if you'll notice, what we can look at when my x value was 2, and I'm going to use this because it works well. My original one was 4. My original y value was 4. Well, since I'm dealing with 1/4 right here, I know that this is going to be multiplied times that 1/4, or it's also the same as divided by 4. So my new y value is going to be at 1. So we can actually do the math here, or we can have Desmos help us out. And if you ever want to sit and work with Desmos with me so that you can see exactly what it's doing, please just let me know and we'll make some time to do that. Okay, so here are some with those stretches and shrinks to work on. So our final learning target was dealing with groups and lots of combining transformations. So here's kind of the steps that we always want to do. So you'll see here I've got my x minus h, and we've got my k and my a value. And a can either be outside or inside the parentheses. So we always want to go in this order. So the first thing we're going to do is we're going to do our translating horizontally. So look at h first. That's going to be where we go first. Then, after we do that, then we're going to look at our a value to stretch it or shrink it. Then the third step is if we have a negative sign, that's when we're going to reflect. And then we're going to finally do k, going up or down. So let's see how that looks. So it's going to go h, a, and then a negative sign if we have a negative sign, and then k. So here's our parent function, which is f of x equals x. And here's my new function. Here's what I'm being asked to do. And then asked to describe the transformations. Okay, so the first thing I want to do is I'm going to kind of rewrite it. So this x is there's nothing with this x. So I know I have my -2 out front and my +3. So this tells me then I have an a value of a -2 and I have a k value of 3. I don't in this one have an h. So there's no horizontal, so I don't have to do that piece, right? So that was step 1, do horizontal. Step 2 is that stretch. So I'm going to stretch it vertically by a factor of 2. So here, let me show you all of this so we can see exactly what it looks like. So the black one is always going to be our parent function. We start there. We did not move it left or right because it didn't have to. We didn't have that value in. So then the next thing I do is this blue one, which stretches it by a factor of 2. So every point is multiplied by 2. The third step I do here, you see in green, is I do have that negative sign, which reflects it. So I see that I have that reflection. And then I translate it 3 units up. So from there, I can go up my 3 units, which gives me my final graph. Okay, so these is definitely always the order you want to go in. So horizontal, stretch or shrink, reflection, and then vertical. Okay, so just make sure that you kind of have an anagram or some way in your head to remember the order that you do that in. Also, this can be helpful with Desmos to go from here, to go from your parent function to this. You can always add some sliders in and see what we can do. Let me show you what sliders look like in Desmos really quickly. Just going to slide this over. So what we can do in Desmos is if I have a times x minus h plus k, so all I've done is I've just typed in our function, and then I can say add slider for all of them. Oh, so here's my parent. So now if my a value changes, look at what happens. Okay, then if my h value changes, where does it go? Where does it move to? And again, with my k value. So you can always add sliders to Desmos and kind of play around and tweak it to make it do everything that you want it to do. So that's a fun way to do that as well. Okay. So here's kind of a real world situation. Here's what we're really looking at. So a cable company charges customers $60 per month. I see a wonderful word here. When I see the word per, that's going to come into play later. For its service, with no installation fee. The cost to a customer is represented by this function. Oh, and I see I'm multiplying here. That's where per comes into play. That means I multiply. M is the number of months of service. To attract new customers, the cable company reduces the monthly fee to $30 but adds an installation fee of $45. The cost to a new customer is represented by this function, where M is the number of months of service. Describe the transformations from the graph C to the graph R. So I see that I start at 60 M, right? And that is my C of M. And then I go to R of M. And I'm just going to rewrite these so I can see exactly what happened. So the first thing I notice that is different is this value right here, right? And this is our stretch or shrink. So my new function, and this one's my new function, is half as much. So this is going to be a shrink because it's half as much. Then I also see this plus 45, which is outside of my parentheses, which tells me it goes up and down. So this is a vertical translation. So I have a shrink and I have a vertical translation, and let's look at these graphs. So here's the graphs, right? The blue is just my parent, my M, just plain old, if I just graphed M. The black was my first equation. The red was my second equation. So you'll see that it was a shrink, so it's a little shorter and fatter. And it's slid up 45 units. So we can take this and kind of just see what we're doing with our functions as well. Okay, so now we've actually walked through everything, so let's just double check on our learning targets. So the first thing we did was we translated and reflected graphs of linear functions. Then we looked at our stretch and shrink, and this value was our A value, right? That's our big, what we're looking at. Then we combined our transformations. So when we combine those transformations, remember we always want to go our H value first. Then we want to do our stretch or shrink. Then if we have any negatives for reflections, and then we're going to deal with our K value. So it is very important to remember what H, A, and K mean and what they do, because we're going to use these for lots of different functions down the road. So now that you've worked through these learning targets, why don't you go ahead and practice on your homework.